meeting is recorded, so if you disagree with that, please go out. So in the previous open cluster management meetings, we talked about the foundation pieces, like how to register a cluster, how to deliver manifest workload from a hub to a managed cluster, etc. So now what about managing application across clusters, right? For example, in a traditional dev, test, UAT, staging, etc. setup, how do I distribute application and promoting an app from one stage to another? How do I deal with multiple regions? The app has to be deployed across all these regions simultaneously. What about migrating from one cloud provider to another? So all these questions are what we're trying to solve in open cluster management application lifecycle space. So when we talk about application lifecycle management, we're not talking about putting a breakpoint in the middle of your application and help you debug it while running on the cluster. It's about helping you take an application maybe from development and promote it across the pipeline. So when the app, which is production, then application lifecycle management also helps you maybe scale out your application when it's needed, or during cluster maintenance, you want to move your app hosting in one cluster to another. So again, when we talk about app here, we're not talking about helping you to develop the app. The core idea is about using a continuously delivery subscription model to actually help manage the running the application once they're developed and created. And this seems to be the industry standard, right? Using a subscription model. So to get the content for the subscription, there's a couple of options that we provide. You can use Helm repo, GitHub, or GitLab, Bitbucket, whatever helps you to store your application manifest data. So again, we have a couple of options that you can use on GitHub for your repo, Helm, other Git providers like Bitbucket, etc. There's also more fine-grained control that you can use with subscription, because you don't want your subscription to be always watching. You can use time windows so that it's only happening during a maintenance period. But we'll get to these details later on, maybe even in
Recording is on.
to discuss. And also we have rolling updates, so we don't want to control the flow of the updates. We don't want the application constantly being stale updating. So again, in application lifecycle, there are multiple components that forms this whole management piece. So we have the channels, which are pointers to the source of truth, the repository. We have the subscriptions, which reference the channel. We have the placement rule that we're gonna talk more detail it later, as well as the demo, because that's what actually driven this multi-cluster scenario. We have the subscription that we obviously need to watches the source of truth and deliver the payload down to your clusters. And then we have the application, which is mostly just for grouping. And again, we're going to talk more about these components later. So in this example, using Git subscription, I created a subscription that says, go get the content from this Git repo. And as it changes over time, instead of having to apply the change directly, we're driven by a GitOps driven model where whatever appears on your Git is whatever being applied, or whatever is applied to your clusters. So using GitOps as the source of truth allows you to do stuff like pull requests and have the review and approval and the full commit history that you can always visit later to see, hey, what went wrong with this this deployment. So obviously, this application delivery system can work in a single cluster setup. So in this picture, we're watching GitHub channel. Where's our source of truth, and then we're subscribing. We're discovering the payload that needs to be deployed into the single Kubernetes clusters. So what gets really interesting is when we actually have a multi-cluster setup like this one, where with the hub and the placement rule, which gives you a dynamic placement behavior. So not only you link your application, the GitHub, to a single cluster, but now you're dynamically delivering all these content to the fleet of clusters under the hub control. So in this example, I have a subscription that's applied to the hub, and using those dynamic placement rules, and I can deliver my application out to the managed cluster that I chooses. So in essence, it gives you an easy and manageable way of controlling over the fleet of application over multiple clusters. So let me see if there's any questions posted. Nope. So I'm gonna go ahead and do a demo and a scenarios playthrough. So one of the main repo is Open Cluster Management Multi-Cloud Operator Subscription. So if you want to play around, go ahead and fork it, and then git clone from your fork and cd into the examples directory. Again, I have with me 2 Hind clusters that I set up. I like Hind clusters because it allows me to test something really quickly and play, and it doesn't cost anything. Right? We're not going over to the cloud providers to ask for a Kubernetes clusters. Everything's done locally. So what I've done set up to save time is I go over to the Open Cluster Management IO. I did the install hub steps to simulate the hub cluster on the left side. I've done the install clusterlet, simulate the managed cluster on the right side, and what I just did as well is I installed our application management. So just a note here, the hub operator is a little bit outdated, so please follow the instruction from install from source if you want to test this. So what I have on the left, it's my hub cluster, and on my right, it's my managed clusters. And after forking the repo, the subscription repo, and go into examples here. So all these are examples that you can play with, but the 2 that I really want to focus on today and talk about is the last 2, the remote git sub. So we can go over some of the CRs that we have. So the namespace for the app, the namespace for the channel, those are not too interesting. So in the channel file here, this actually points to your source of truth. So when you clone when you fork the repo here, here's a path that you might have to edit because I added it to point to my Git repository. So this makes it to watch for, hey, this is the repo that I'm watching for. So the placement rule, this talks about where you're gonna place your applications into the managed cluster from the hub side. So right now I have it set as an environment. The managed cluster has to have a label that has environment mesh dev, and in my examples, I'm going to talk more about it because I feel like placement rule that dynamically driven is what sets us apart from the other application delivery systems such as like Argo CD, etc. So we have the subscription model, which obviously points to the channel and the placement rule. But here's another interesting part. So here's the annotation with the GitHub branches, where we're talking about, hey, we're watching this master branch, but you can talk about it can be any other experimental branches, and then the path to that branch to the folders in example remote git sub op. So when I say git sub op, how that is actually the that's actually the folder once the subscription is applied. That's this is the payload that is being watched and being delivered. So in my example here, it's just a simple ingress deployment. So when it comes to the demo, I'm gonna make changes here, and then it will reflect down to the managed clusters. So I think I already cloned the repo. I'm gonna go ahead on my hub side here. I'm gonna go ahead and apply the remote git sub. So which does what it does we're applying all those we're applying the subscription on the hub side. So unintentionally. So essentially right now the placement rule is environment depth, but it's not resolving into anything because on my managed clusters that register right now is on my right side. My label is actually environment test. So this is not gonna propagate any application to my managed clusters because the labels do not match. If I change that to dev, in the subscription should reconcile. For the first, we'll check the placement rule. So now it finds the placement rule cluster one, which is the name for my managed clusters. So now the subscription will show on the hub side, hey, I propagated into cluster one, and these are the packages deployed, and we can see if that's true or not on the managed side. Okay, I see the namespaces. So we can see the application being delivered from the hub to the managed clusters. So where GitOps becomes powerful is I can go into the ops folder. Okay, and so say I want to scale out this environment because there's I'm doing some performance testing, I'm doing some, or in production I need more performance. So I can see on my Git here. So usually you create a branch, like follow best practice for Git, obviously. But as a demonstration, I'm just gonna push to the master. So we can see on much work is. So I just changed the replicas from 1 to 3, and we have that commit history here. Well, so it gives you a track. I guess I should create a branch which shows off the pull request and do a step approval, but maybe I'll do that afterwards. So now the subscription will watch that, and then it should on the managed side scale out to 3 replicas. So as we can see, before it was 1, it's now 3. So let me do a step for approval. So I'm scaling back the webcast. Of course, you can do other modification when you play with it. So someone who's managing the operation, you know, as someone who's doing the operation might not be the same one as who's managing the entire infrastructure, right? So now you can create the pull request. So I guess my file is a little bit outdated. So this this is not intentional to happen, but it also gives us a good way. Hey, there's something wrong. So this change is not going to go through because it's not going to have the approval that's needed for for this to work. Oh, the wrong I'm on the wrong thing. I'm on the wrong repo. So where so on my repo on a git commit that I just pushed, I'm scaling down from 3 to 1. So I'm going to create the pull request. So as approver, I can come in and look at my pull request, and I know I'm just imitating. As an approver, I can imitate, come in here and look at the pull request. Hey, this is what I want to do, and I can either approve or disapprove, or merge or not merge, and leave behind comments. Right? So in this case, we're gonna go ahead and merge test. So once it's merged, then we can come back here and we should be. So there's an interval that we watch from these watching the GitHub repositories. So I'm guessing the interval hasn't hit yet. Because if I go on so it should be 1. So maybe we'll wait a little bit to see if there's an issue or not. This is free watching the master exam. Oh, okay. So finally the interval takes over, and then we're now back to our scale of 1. So really, that's the basic of the application description models. And I really encourage everyone to go ahead and fork the repo and give it a try, and follow the open cluster open cluster management.io steps, which gives you simulate the hub and the manage. And then you can play the application model and see what we're trying to do here with the multi-cluster management across the plane. So I'm going to open it up right now and see if there are any questions. Are there any questions that anyone have? Okay, it seems like there are no questions. So I want to take the second half of the meetings to talk a little bit about to go through what is in our community issues. So I'm just gonna triage these issues openly. So if you're not interested in participating, feel free to drop off. So first issue is Slack channel. So I think as I mentioned, we already have a Slack channel. Yeah, I mentioned five. So I think we can close this one. Actually. I think this one should be where.
Mike, I'm going to share the issues list. I still see the page on your deployment YAML file.
Oh, okay.
Actually, see
I can see the issues.
Can you see it now? I open in a new form.
I can see it, Mike.
Okay. So information. Okay, so this one is taken care of. Oh, so this is the one that we're currently working on, and this is our we're working on it internally as well. And one of the main offenders actually the demo the repo that we just show the application lifecycle for you, and that's one of the one that is open as well. If we remember correct, our foundation. Okay, so our foundation repos is also, so it seems like there's at least a few repos that needs to be turned into the main branch. Smart branch. Okay, where is already working? And I'm converting the ones that we have open. Okay, I think that's about it for this week's meeting, community meeting. Are there any other questions that anyone have regarding the community or regarding application delivery? If not, then I'll go more in depth with each of the application components next community meeting. Thank you everyone for joining. Have a nice day.
Thank you.